1 2 1 2 3. Give me a second. Okay, hello. Today, as I promised, we start organic chemistry and we start from beginning. So no need to be prepared for this lesson. We will start from different type of formulas. I show you. If you forget everything, it will be good place from start. So today we will I will teach you how to understand all these different type of formulas. We have 1, 2, 3 types, and in the end we will talking about hydrocarbons. We will not study chemical property or nomenclature because it's a separate chapter. We just study how these molecules look like. And at first we need to know what most important and most hard and most big formula, what you must be able to create in your brain. It's structural formula. It's in left. It's more important. It's most informative. It's biggest one, but at the same moment it's very big and require a lot of space. So at first we need to understand how we draw these different type of formulas. So if we're talking about structure, it's most informative, most detailed, and if we split these molecules into 1, 2, 3 fragments, we can create a condensed formula. And if we number these fragments as fragments 1, fragments 2, and fragment 3, we will get CH3, CH2, CH3. In skeleton formula, we have more compressed way. In skeleton formula, we show only carbon-carbon bonds. It's mean we show carbon bonds, this one, and it's all. We have only 2 carbon-carbon bonds, and each angles it's carbon atoms. So structural, condensed, skeletal. By using structural formula, you can predict property, you can name compounds, but it's too messy. And if we have skeletal formula, we can create condensed formula from skeletal formula. We have bonds, so carbon, 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 carbon. And all rest connection be with hydrogen, because carbon have valence 4. It means each carbon have 4 bonds. So and H, 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 H. And if we want draw condensed formula, 1, 2, 3, 4, and let's, for example, 1, 2, 3, 4. CH3, C, CH3 in brackets, because it's what I know. With number 4 groups, it's separate, but in condensed formula we must be able to draw structure in line, in horizontal line. So it will be, oh, one moment, I will make mistake in my formula. Yeah, now it's correct. And another skeletal formula, it's cyclohexane, structural formula, carbon, 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 and all rest bonds will be with hydrogen. H, 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 H. For this structure, we can't draw proper condensed formula in line, so we'll write it like it's here, CH2, 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 and CH2, CH2, CH2. For structural formula, for condensed formula, and for skeleton formula, you can draw correctly by different way. It's not EU Pack nomenclature. You can draw same molecule differently. It's okay. So I draw like this, but maybe someone rotate by 90 degree and get same result. It's also will be right. In most cases, this type of formula we need just for imagine this and predict property count empirical formula. For example, for this compound, condensed formula were useful for counting molecules because C6, H12, and this C4, H1, 1, 2, 3, 3, wait, 6, 8, 8, 8. Another questions, it's also compounds, but with very strange formula. It's cyclopropane. It's unstable, very unstable. All other connections with hydrogens. No, errors. I make a mistake. Each carbon connected with 1, 2, 3, 4 different bonds, like this. And I'm not write empirical formula, condensed formula. It will be very not informative. CH2 and empirical formula C3H4. O4. So what you must memorize for hydrocarbons? You have only 2 fragments. Carbon with 4 bonds and hydrogen with 1 bonds. And with hydrogen we have only 1 option, but with carbon we have many options. For example, we can draw also carbon like double bond and 2 single bond, or 2 double bond. It's rare, but sometimes exist. Or triple bond and single bond. In any case, carbon always have 4 bonds, and hydrogen have only 1 bond. Most important, skeletal structural formula and valence of hydrogen and carbon. It's most important what you need to know and to understand how compounds will look like and what empirical formula, what structure. And if you know structure, you can predict property. For example, we have skeletal formula, and we can draw condensed formula because every carbon connect with 4 different atoms or connect with 4 different bonds. I recommend you use, for saving time, especially if you have paper, marking as dots any hydrogen atoms for counting. For example, here it's 1, 2, 3, 4, because what I mark, all this, I name it hydrogen 1, hydrogen 2, hydrogen 3, hydrogen 4. It's all carbons with 3 bonds. It's 1 bond, 2nd bond, 3rd bond. So 1, 2, 3. So if 4 bonds, each carbon forms, so it means these molecules connect here with 1 hydrogen atoms, here with 1. Here, for example, no carbon atoms at all, no hydrogen atoms, sorry. And here, no hydrogen atoms, and 5, 6, 7, 8. So H8 and carbons, with carbon it's more easy. We can split by half, and carbons 1, 2, 3, 4, 5 multiply by 2. So C10, H8. And skeletal formula and condensed formula will be CH, 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 carbon, 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 CH, carbon, CH, carbon, CH. So in this case, condensed formula not very informative, so skeletal formula, marks, and empirical formula, because it's 2 big molecules. Another example, we can write condensed formula, but it will be too big. So for finding empirical formula, at first let's count carbons. 1, 2, 3, 4, 5, 6, 7, 8. So C8. It's more easy. Now let's count hydrogen atoms. Here too, because we have only 2 bonds. Here too, we have only 2 bonds. And here too. And here 1, 2, 2, 2, and 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So C8, H14. Not bad. Oh. Here more hard, because it's even not look like molecules, but actually it's very popular molecule, especially if you visit forest where a lot of always green trees. So at first carbon, and here let's start make some tricks. So 1, 2, 3, 4, 5, 6. We're marking it like C6 fragments. And 1, 2, 3, 4. It's C4 fragments. So overall, we have C6 plus 4, or we have C10. We group in all atoms because if you're dealing with many atoms, if you make mistake, you must be able to catch this mistake. If you count more than 10 and more than 10 atoms, sometimes you can make mistakes. So my advice, split into fragments your carbon atoms and your hydrogen atoms. For example, for hydrogen atoms, 1, 2, 3, 4, 5, 6. So it's H6 fragments. Another 1, 2, 3, 4. These fragments H4, and 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, in these fragments it's H6. So we have hydrogen 6 plus 4 plus 6, or C10H 16. 16 look like right. So what I did in these lines, if you count many objects, more than 10 objects, you must cut it by fragments, because if you count in one time all atoms, all hydrogen atoms and all carbon atoms, and make one mistake, you probably, for catching these mistakes, need many times make the same, and it's very likely you repeat this mistake. But if you group in your counting, how you count atoms, it's help you. So right now by looking by eyes, catch everything okay or not, because if in one of these loops I will make mistakes, I can catch these mistakes. But if no fragmentation, I can't. Especially this way informative and powerful if we're dealing with very, very big molecules like this. If you need to find empirical formula, it's very likely you make a mistake. So let's start from easy fragments. Count carbon atoms. Count, example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wait, too many. No. It's 7, 8, 9, 10. So it's C10. Another fragments, 1, 2, 3, 4, 5, 6, 7. These fragments C7, and these fragments it's C3. So empirical formula C10 plus 7 plus 3, H still unknown, NSH. With H, it's hardest part. So let's start. 1, 2, 1, 2, 3, 4. Here 0, 0, 0, 4, 5, 6, 7, 8, 9, 10, 11, 12, 30, 40. So in all these fragments we count C14. It's too many. And one moment, I will make not very successful loop. H14. Second fragments. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11, let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. H11 and its fragments. And last fragments. 1, 2, 3, 4, 5, 6, 7, 7, H7. So we have H14 plus 11 plus 7. We will get C20, H. It's 25, 32, 32. So, like this. One moment. Like this. Okay, and a couple more questions. So, carbons. Carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 30, 40, 50, 60. It's relatively easy. It's C60. And hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Surprisingly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, H10. So empirical formula C16, H10. So if a molecule were symmetrical, no needs to split it by a part. So for finding formulas and predicting structure, you need to be able to write structural formula from skeletal, from condensed. And as I promised, hydrocarbons. We have 4 types of hydrocarbons. Main types, it's when each bond separate, it's like alkanes. I write condensed formula, CH3, CH3. If you have double bond, 1 or 2 or more, CH2, CH, CH, CH2. And with triple bond, CH, triple bond, C, And special case if we have three, in most cases three, but not always three, but if you have many condensed double bond, we have compounds which we name aromatics. It's C6H6, it's benzene. And all these fragments consist of only carbons and hydrogens. So what you must memorize, it's for organic chemistry at first. Every organic molecules consist of carbons and hydrogens, with very rare exceptions. Carbon necessary, hydrogen sometimes. And you must understand differences between skeletal structure and condensed formula. Structural formula most informative, it's need especially if you need naming compounds or predict reaction, even if you forget what's happened, how molecules react. If you know structural formula, you can make some suggestions without knowing chemistry by looking on structural formula and imagine what theoretically may be, even if it's looks weird, do it. And if you need solve questions about finding empirical formula by using different skeletal formula or condensed formula, grouping compounds by fragments. It's mean something like cutting by fragments, count in fragments, and then when you count fragments, you get a final result. And it's decrease the probability to make error, but it requires more time. So thanks for all who watching, and visit my next webinar. It will be Wednesday, very soon. Thank you. Bye.